reactor pressure vessel, the nuclear reaction and the associated release of thermal energy takes place. In a pressurized water reactor, as in this case, the reactor pressure vessel stands about 12 meters tall. The walls are about 25 centimeters thick. Inside is where the fuel assemblies can be found. In pressurized water reactors, about 150 such assemblies are installed. A single fuel assembly is composed of many fuel rods. A fuel rod is about 5 meters in length and has a diameter of about 23 centimeters. The actual nuclear fuel is found inside of each fuel rod. Small nuclear fuel pellets composed of enriched uranium or plutonium make nuclear fission chain reaction possible. In the fission chain reaction, thermal energy is released. Water is needed in order to absorb the thermal energy and keep the chain reaction going. Inside the vessel, the water is heated to over 570 degrees Fahrenheit. The water does not boil, however, since the pressurizer maintains the water pressure constant at around 160 bars. The heated water is eventually pumped to a heat exchanger, also called steam generator. These are typically in the form of a shell and tube heat exchanger. Hot water flows through the U-tubes, heating up the metal of the pipes so that any water inside the heat exchanger begins to boil. The resulting steam is eventually fed through a set of pipes to the turbine building. The steam first drives a high-pressure turbine and then is typically fed to 2 low-pressure turbines. All of the turbines are connected by a spinning shaft to the electrical generator, which in turn produces AC electricity from the shaft's rotational energy. The steam is converted again into liquid form in a condenser, and then returned back to the steam generator. The water needed for this often comes from an adjacent river, or is cooled in a cooling tower. The water circulation systems are always kept separate from one another. Water in the primary circulation system never leaves the containment building. This water is radioactive, since it has been in direct contact with the fuel rods. Water in the secondary circulation system is used to drive the turbines and is not radioactive. The cooling circulation system provides cool water and is used to condense the steam